Okay, boys and girls, let's do an example problem. Let's say I measure the mass of a beaker. It's a container we use in chem lab for general purpose, for holding liquid solids, whatever. Say we measure the mass of a beaker, and it comes out to be 71.8 grams. All right. And then we put a sample, let's say a chunk of magnesium, into the same beaker, and that chunk of magnesium we know weighs 23 grams. I simply want to know what would this total mass of the beaker and the magnesium be. All right, so that's going to be a summation. We're going to add them together. Now, just for purposes of making things a little more clear, let's get rid of the grams units and just concern ourselves with the numbers. What is the combined total? Now, if we're doing this addition by hand, and I suggest you do it by hand, at least until you get used to sig digs here. If you're doing it by hand, you set up the two numbers in column form, aligning the decimal points. Once the decimal points are aligned, you just go ahead and add up each column. Right? 8 and nothing is 8. Right? 1 and 3 is 4. 7 and 2 is 9. And of course, you just drop the decimal point down in between the 4 and the 8 here. So my answer is 94.8. And that would be grams. But is that a correct number of sig digs in the answer? And in this case, the answer is no. Right. What we're trying to do in this case is analyze the two numbers we added together and look for the position of its last sig dig. In 71.8, they're all significant, but the last sig dig is the 8. In the second number, 23, they're both non-zeros, so they're all significant. Its last significant digit here is 3. Which one of these two numbers has this last sig dig in the highest place value? Right? Place value increases as you go to the left. So another way of saying this is our last sig dig has to be furthest to the left. Right? Which one of these two numbers has its last sig dig, either the 8 or the 3, furthest to the left? Right here. Okay. Last sig dig is higher in value. Right. So we want to mirror that down in the answer. Right? Just for a quick review, this 8 is in what position? It's the tenths position. The 3 in this number is in the ones position. A 1 is bigger than a tenth. Think about it. So we want to mirror this last sig dig place value in the answer. Our last sig dig in our answer we need to have sitting here in the ones place, which means we have to get rid of the 8. Right, but before we get rid of the 8, we ask ourselves, do we round up or down on the 4? Well, 8 is bigger than 5, so of course we do round up. So our answer is, in fact, correctly written as 95. Right? The last sig dig in this answer, 95, is the 5, and the 5 is in the ones place, which exactly mirrors what we have up here in the two numbers we added together. All right? The two numbers we added together, the 23 had its last sig dig in the ones place. It's higher. So make that mirror that in the answer. Okay, I posted 12 addition subtraction problems on Google Classroom this morning, and you're supposed to carry out the indicated operations and then round your answer to the proper number of sig digs. So let's go through and work on one or two of these, sort of get you going. All right. Let's do problem number 1, which is 273.4. Again, let's say that's maybe seconds. We're measuring time for some reason. And then some other event that we measure, 11.37 seconds, for whatever reason. We wanted to take these two time measurements and add them together. Right, now we're not going to put seconds down here, just so that it Makes our problem a little bit cleaner. We don't have to worry about looking at units. Anyway, the way I gave you these problems, that the addition or subtraction problems was already in column form with the decimal points lined up. All right, let's just go ahead and do this addition. All right, nothing in 7 is 7. 4 and 3 is 7. Bring down the decimal point. 3 and 1 is 4. 7 and 1 is 8. And then we bring down the 2. So our answer is 284.77. However, we have to follow the rules for significant digits for addition and subtraction. And again, if we go back and look at it, the answer to an addition or subtraction problem will have its last sig dig in the same place value location as the number whose last significant digit that we added together is in the highest place value. So we need to go back here, look at the location of the last sig dig in each of these numbers. Where is the last significant digit for the 273.4 data? Well, they're all non-zeros, so the last sig dig is in fact the 4. All right, the 4 is a significant digit. How about the 11.37? Well, they're all non-zeros again. All 4 digits are significant. The last of those significant digits, the 7, however, is in the hundredths place. Which one of those is the higher place value? Well, it's the one that's furthest to the left. Remember from the previous example. All right, as we move from right to left in our number, we go to higher place values. All right, so which one of these two numbers has its last significant digit furthest to the left? Well, it's this guy right here. Its last sig dig is in the tenths place. So we need to mirror that in our answer. Round our answer to tenths place. Okay. So 284.77. Here's the tenths place, so we want to cut it off here, get rid of the 7. But of course we have to look at that 7 first and ask ourselves, will this 7 cause this previous digit to go up 1, or do we round it down, leave it the same? In other words, well, 7 is 5 or greater, which means that the number in front of it gets rounded up. So the correct answer to this will in fact be 284.8. All right.